My name is Geir Tore Knudsen GT, as you said, and I'm the leading advisor for inspection technology in Equinor. Today, I will try to give you some insight on where we use robotic technology in our value chain, and maybe also touch into requirements and a little bit on technology development as well. But please note that the examples I'm showing on the slides, they do not represent all technologies that we've been looking into, but just some of them, just to give you a picture. Let's see. First, a couple of slides to show you who we are as a company and what business we're in. We are a broad energy company, as many of you know, over 23,000 employees across the world, present in over 30 countries and over 8,000 suppliers we use. And I guess many of the suppliers are present here today. A bit on our strategies, which is always safe, high value, and low carbon. So now let's see how robotic technology fits into those values and strategies. Why do we use robotic and technology and drone technology in Equinor? And for the strategy, always safe. Of course, this is all about minimizing the HSE risk by using robotic technology when we perform operations subsea, topside, in confined spaces and at heights, because we don't want human beings to be in those areas if they don't need to. If a robotic solution can do it, we want to use it. And regards to high value, of course, it gives us a reduced cost if we plan it correct, by excluding time-consuming and expensive support activities like scaffolding and blindings and planning and all of those activities. And for me, working with inspection, of course, the quality of the data is increasing by using robotics that can carry new sensors that can give us more accurate data. And this sentence, I used to call it the Kinder Egg sentence because it gives me a lot of things that the Kinder Egg gives me. So it sums up the bullet points quite nicely. We also follow the nine life-saving rules that many others do, and the confined space and the working at heights rule fits right in with robotic and drone technology with regards to having a positive HSE impact. When it comes to requirements, we have now requirements for working environment and inspection that involves use of robotics or automated systems, like it says here. And it says that remotely controlled and automated systems shall be the preferred solution in the working environment requirements. And also, we say the same wording in inspection, but with inspection requirements, we also say that we should use this technology if the data quality is equal or superior compared to traditional inspection solutions, because it's all about the data. And so if you compare it to how we did it before, we did it the old way because that's what we knew, we were happy with that, and sometimes a clever guy, forward-leaning on new technology, comes with a robotic solution and drone and say, let's try this, and we do it. But now we try to flip it around with getting it into our processes and say that we should first look at using automated systems, and then if that can't do the work, then you can go do the traditional way. And also, as many people in this audience know, we are a part of HOIS and been for many years. And we also makes reference to HOIS documents, RPs, and guidelines in our requirements for inspection. Like this, you see on this slide, the RP58, the recommended practice for internal inspection of pressure vessels, and also the G005, use of drones for external visual inspection. So really good documents that we can refer to in our requirements. What categories of robotic solutions do we have? I will quickly go through the areas where we use robotic technology, not the technology in itself, but where do we use it? Starting from the deep subsea and all the way to the sky. And again, please note that this is not all the solutions we have been looking into. So the important thing is where we use it. Okay, we're starting the deep subsea. We have used ROVs for many years in the company and built up a good experience in the field of using this. And we have our own subsea division for these kinds of operations. We use a lot of operators, contractors to do this for us. And we are increasing the use of ROVs. And the goal is to reduce vessel operations offshore to a minimum by increasing the use of so-called residency ROVs that can live subsea for a longer period of time, like this example shows. So this is an important area for us. Moving up from the deep subsea into shallow waters, we use mini ROVs for different kinds of inspections, like inspections of the seawater intake for land facilities, filter inspections, water tanks, ship hulls, and so on, like you see in the picture. So that's also a off-the-shelf, easy way to do inspections. Still in the water, but moving up to from the shallow waters to the splash zone, risers and other structure offshore and so on. We use different kind of solutions to perform different inspection and maintenance operation in the splash zones area. So this is being used more and more. Some of the solutions you can see here. Now let's move up from the water and topside, offshore and onshore assets. Here you see some belt-driven and leg robots, operator robots that we can call it, that can also do inspection tasks for us. You see the list of tasks that we are looking into, but not limited to that. So this is you have all heard about the 4Ds when robotics come into play here: dirty, dull, distant, and dangerous. And of course, these kinds of solutions can help us with many of those Ds, if you can call it that. We're also using robots for welding. Maybe some of you have heard about Weldar, which is an idea that came from one of our onshore plants in Norway, Kjellbergodden. So the concept is to perform weld repairs of corrosion damages on process equipment on site with the equipment still in service. So of course, that's a big value for us. And also, if we go into confined space, we have this solution, Marcus robot solution. It is a modular concept that you can tailor build to what you want, really. And initially, it was designed for painting and sandblasting, but is now growing to be a solution for also other tools and operations, like you see on the picture to the left. Where we have a welding, in fact, it's a Weldar robot also mounted on the Marcus robot. So here we are still in the confined space. Here are some examples on crawlers, mainly used for internal inspection, that we use whenever we see it fit for purpose. And these two have a really high definition camera, and it can also do wall thickness measurements. But the difference between these two solutions is that the one to the right uses vacuum technology to stick to the surface, which of course is ideal for doing inspections on stainless steel, austenitic, non-magnetic materials. And the crawler to the left, you can see, have magnetic wheels. I guess you have seen both of these solutions before. But of course, you can see that they get around and they get the job done if you want to do the visual inspection and some wall thickness measurements. So we use these types of robots when we can, in all kinds of equipment, if it's safe enough, of course. So over to the drone, up to the air. In 2012, we did our first drone inspections, both on and offshore in Equinor. And most of our business areas are using drones today for different types of operations. And we use drones for confined space and open air, and I will show you some examples in a bit. And as you all know, the development of new tooling on drones goes really, really fast, and we do experience and expect increased use of drone technology in the future. No doubt about that. Here is a good example of increased use of drones, or maybe I should say another way of using drones that we haven't done before, and it's concerning use of drones for light cargo transport. So we have now our own drone control center in Sandsli in Bergen to coordinate drone operations from land to offshore, and also between offshore assets. So it's getting big, and more operations are getting available for us. A little bit on increased data quality that we talked about a few slides ago. This shows the quality that we can get by using crawlers. And as you see on the 3D model, you can see one of the crawlers that I showed hanging on the ceiling inside the vessel, looking into a nozzle. And this is a pitch black environment. So it's really good pictures that we can get in these environments. And as you can see, we can zoom in to this nozzle and even read what's written on the valve in the end of the nozzle. So it's quite remarkable. Another one example of camera optic development. These are the same vortex breakers we have taken pictures of. But the picture to the left, the picture is taken with a handheld camera through a nozzle or manway. I can't remember what it was. But as you can see, it's quite a big difference between those pictures and the quality and what you can get out of the pictures. And if you see the picture to the right, you can see the date 2019 on the top left corner of that picture. And that's 5 years ago. And if we think about the development on optics, I guess you can get better pictures than that today. But of course, these kinds of pictures, this gives us opportunity to take action with much better accuracy than before. This is a HSE example. You see the drawing the size of that and a normal sized man standing inside beside it. This vessel is 1 meter in diameter, and the nozzle, as you can see on the 3D model, is much longer than on the drawing. And this is a buried vessel, and you can think how challenging it is to make an evacuation plan for bringing a person out of this vessel if something happens to that man. So it's a no-brainer to do what we did here and drive down a crawler and do the visual inspection. And also we did UT point measuring on the shell. Okay, over to the drone technology. As many of you know the terms UAS and RPAS, but for those of you who are not familiar with the terms, UAS is short for Unmanned Aircraft System, and RPAS is Remotely Piloted Aircraft System. But both these terms describe the whole drone system that include the aircraft, the control station, and also the communication link between them. But keep in mind that the RPAS specifically indicates human control of the drone, whereas UAS can also refer to autonomous. So it's a fun fact to take with you. Okay, there we have other requirements come into play when you're flying something in the air. We have our own requirement process for safe use of drones in the company. We have all the requirements for the governments and what we want in that process. And we're also working on an operation manual in Equinor to do low-risk operations ourselves and not be dependent on contractors to do the flying, but only for the low risk and low-hanging fruit operations that we call it. And also we have a flight safety organization in Equinor that are responsible for everything moving in the air, including drones. So we rely on them when we have a new contractor, for example, that are going to fly for us. They are involved. And of course, we rely on the NCAA requirements that are in the safe use of drones requirement process. So it's not just to start a drone and start to fly. It's a lot of requirements we have to follow and do everything by the book, which we do. Some examples on where we use drones. As I said, we started in 2012, and this was the kind of operations that we started with. The easy low-hanging fruit operation is, of course, the flare stack and the flare tip. And we've done this annually, and we have programs on doing this because many of those flares are continuously burning. So we can't expect it going up, of course. And we use drones because we get these kinds of pictures. This is an old picture, and back to the development on optics, we can even get better pictures than this. And here we have a standoff on the drone for about 30 meters, I think, because of the heat of the flare from the flare. So of course you have enough opportunities to get a good visual inspection and see deforming and cracks starting. So it's a good way to use a drone. And also we use drones for internal inspections. Many of you may have seen this before, but I think it's a good slide. You see the 3D model to the right. You can see this is a boiler, and the big circle shows where we have the big silencers in this chimney. And before the drones came into the picture, we have to build a scaffolding from the bottom of this chimney and up to this brackets where the silencers are resting. or lying on. And all these equipment, scaffolding, people to build it, and inspectors and everything, they have to go through this manway. So of course, it's a no-brainer to fly up if you are going to do a visual inspection of these brackets, and you get the pictures that you show, that you can see on the left upper picture. And also we're looking into using NDT, doing NDT inspection with drones, and these and others solutions can help us with that. So as I mentioned earlier, a lot of new tooling is coming to the drones, but we need to qualify it and see if it's good enough compared to doing it the traditional way. And that's what we're doing now, looking into it. And also warehousing onshore are using drones. Instead of lifting down the pallet to count the parts in pallets, they can fly up and do that job instead of lifting down the pallet, which is a HSE hazard in itself. Offshore asset inspections, they do more or less the same thing that onshore do, but they also have below deck inspections that can be challenging. And they also do environmental inspections. They can use the drone for first responder tasks and do emission measuring and so on. So we use drones a lot also offshore. Yeah, I mentioned it earlier. This is the drones that we use to do the light cargo operations from onshore to offshore and between the facilities. So it's a good value for us to use drones instead of boats and helicopters to do easy tasks, light cargo operations. Yeah, renewables. We are getting big in renewables as well. And Martin, you mentioned that you had a presentation from us earlier on drone inspections on wind farms and turbine blades. But I like this slide because it illustrates to the left before and now. And I feel sorry for the guy hanging on the blade. I can't help it, but yeah, call it a no-brainer if you can use drones to do autonomous, automatic, using AI to find defects and so on the blades. So this is the way to go, of course. Regards to future use cases, we are looking into drone-in-a-box solutions that can do different kinds of tasks for us. So residency drones, maybe you can call it that can be in the facility or outside and do planned tasks that normally people do. And it can also be used for first responder tasks, perimeter monitoring, yeah, all those things that you see listed up there, but not limited to, of course. So this is one of the future use cases. So a quick summary of the robotic journey so far. I couldn't take a deep dive into everything, so this was the summary of it. But at top, in the beginning, in the implementation phase, we face challenges like all other do, because the users on the assets, they were not familiar with the different technologies. Everything was new, and we know how the old ways of doing it is, so that's easy to choose. So we experienced some reluctance in the beginning when introducing these new solutions. But today, after years of maturing the technologies and the quality is getting much better, and we can show the values on POCs and planned jobs. We now experience embracement in the company in general for robotic solutions, where, of course, we use it where we can. After a thorough risk assessment, if it's safe enough, we use it. So, and the way forward for us is, of course, to continue to be part of projects, including robot technology that can give us safer operations, more efficient operations, and of course, data is everything. So we get improved data. That's what we're after, so that we can do more precise actions when we need to at an early stage. So that was all I had, and I hope that you got some insights in the use of robotics in our business areas. And thank you for listening.
Thank you very much, GT. A wonderful range of different applications, and it's good to see how it's moved on from the presentation we had 2 years ago. And Vikesh, would you like to give the first question?
Thank you, Martin, and thank you, Geir, for sharing an excellent overview of all different applications from subsea to drone in the sky. Geir, in two of the slides, I think slide number 17 or 18, you refer to improved or increased quality. So can you share your experience on what is your base case or benchmark when we say improved or increased in quality, or is there any criteria that you follow for defining quality?
Yeah, of course. Thanks, Vikesh. I mentioned not the criteria, but the guidelines that HOIS comes with. It's of course important for us to get as good benchmark quality as possible. But as I also showed on one of the pictures, you can see the difference between doing it with a handheld camera in your hand and what you can place on a drone or a robot. So of course, anyway, it's to the better to use those kinds of technologies to get increased data quality. But yeah, I guess it's many initiatives going on now on benchmarking on what's good enough and what's not. But the HOIS recommended practice and guidelines is a good starting point.
Yeah, very good. Thanks, Geir. Back to you, Martin. You're on mute, Martin.
Interesting comment from Blair Nunn in the chat. He's got to head off to another meeting, but he was very interested to see the wide range of developments and looking forward to further collaborations within HOIS on those activities. When we had a recent meeting on subsea, GT, there was a comment that about 50% of the time is planning a subsea inspection is spent with sort of planning and simulation, particularly the use of simulation. You showed an example of simulation used in a sort of factory type environment to look at access and using a digital twin. How common is that in your robotic activities? Would you normally, if you're looking at the access requirements, would you normally try and use digital tools or digital twins just to check the flight path or to check that a robotic access is feasible?
Yeah, thanks, Martin. Yeah, we try to do that if that solutions have that possibility. We have our digital twin and we use that as much as possible, but that doesn't show the inside of equipment if that's the case. So, but there are solutions that can simulate internal operations and external. So we try to do that as much as we can. And when it comes to subsea, that's, as I mentioned, this is an own division for us. And I'm pretty sure that they also have simulation tools where they can go through the operation before they do it. So it's planning is the key to get what you want.
Thanks, GT. Anyone else, if you've got a question coming in your mind, either put your hand up or add it to the chat. Another while back, I saw details about caterpillar crawlers being used on wind turbine blades. There's a system where you could drop a caterpillar crawler onto the blade from above, and it could carry out things like ultrasonic scanning or chirography. As I did see one of your images had a caterpillar crawler. Is that something that you've been using or trialing on wind turbine blades?
Thanks, Martin. As far as I know, we haven't tried it yet, but we are looking into different solutions that we can use on and inside the turbine blades. So definitely, we're looking into. As I mentioned, I think it will be more and more use of robotic and automated systems on the renewable sector. Okay, now that'd be interesting to see how that develops. I recall about 5 years ago, there were a couple of ultrasonic scanners developed by, I think, Sonomatic and Oceaneering for going inside monopiles and for inspecting the welds for cracks. There's a question here from Colin Black. Excellent presentation, GT, much appreciated. The NSTA and Energy Transition Norway supported technology platform showcases over 132 robotic solutions. Are you able to find further details on specific robotic solutions used by Equinor so we could share with all the operators, end users, HOIS members? I don't know what the answer is to that. It's given a web link for that platform. You've been very kind and you've provided quite a wide variety of. Yeah, it's further details on specific solutions used by Equinor. It's I've gone through some of them now, and as I said, we are having different kinds of initiatives on other solutions as well. But that has to come at a later stage, I think.
Okay, great. Yes, Colin, GT, maybe it's worth getting after the event, getting together and seeing if there's things that the NSTA are looking at that might, and Equinor are trying that maybe a basis for collaboration.
Yeah, maybe.
Stuart Kennedy. Just this question about. What do you think? You did show such a variety of different applications, and you mentioned obviously the early ones like flare stacks coming because they were so obvious in service and access sort of issues. What do you see as the next growth areas in terms of your use of robotics or drones, either topside or subsea?
For us, you mean?
For you, yeah. What do you see?
The next. We have looked into it for a while, but also using robotics in storage tanks, in service inspections, and so on. But I said we have been on this journey for some years, but it's now that the ball starts rolling, and you know when you do inspections with different kinds of solutions, new areas where you believe you can do it comes along. So I think I can't say what kind of solutions and what areas, but hopefully we will get to do more inspections with the use of automated systems on piping and all our equipment really. As long as the data is good enough and if it's safe enough.
Thanks, GT. Question here: Are you able to discuss any updates on the subsea Wi-Fi deep star project specifically for AUVs?
No, sorry, I can't say anything about that.
Okay, it's fine.
No, sorry.
Question from Patricia Lidgard. Excellent talk. We're using Spot within the nuclear industry.
Yeah.
Can you expand on what applications you use it for? I'm not
Yeah.
sure myself what Spot means, but
Yeah, thanks. What we are using it for, we are testing it now in a wastewater treatment plant. So that's the first step for us to see how it does the work. So we haven't used it in the process areas yet because it's non-ATEX. But we are working on that issue. But we start using it where it's not that classified area.
Okay. Another interesting area in use of robotics is in deploying NDE type methods. For example, from drones doing spot thickness measurements, and I guess using robotics, you've got a much wider range of possibilities. A lot of examples I see tend to be visual inspection, but have you investigated use of these robotic type systems for NDE methods, corrosion mapping, spot measurements, etc.?
Yeah, thanks. As I mentioned, we have used Waygate's bike crawler, which has we have done wall thickness measurements with this solution, and we have tested also drones for the same purpose. So that's what we've done.